Now suppose we have a set of 2D images of a scene. We need to perform a set of 3D tasks like camera pose estimation, depth maps, point maps, and tracks. But usually the traditional methods employ separate pipelines for each of these tasks, or for advanced optimization test time optimizations for these camera like bundle adjustment or structure from motion. But VGGT wants to prove that all these 3D tasks can be done by using a single forward pass through a specially designed transformer. So VGGT stands for Visual Geometry Grounded Transformer, and so we want to create a set of representations that are shared and geometry aware. So the architecture is very simple. First, we pacify each input using a DINO backbone and create these tokens. And once it is being done, then to make sure that the images or these token sequences are geometry aware, we add camera tokens. So each camera tokens encodes the camera's intrinsics and extrinsics. So also 4 register tokens are also being added to these token sequences to make sure that they work as global aggregation buffers. Also, and like since we want to estimate these camera parameters and depth maps, we need to have a reference frame. To make sure that there is a well-defined reference frame, they treat this first image differently. So the first image's camera token and these 4 register buffer tokens are being treated differently when the tokens are being processed inside this uh, alternating transformer. So the alternating attention part is also really interesting because the first like the so the image should be aware of itself and the set of images must be aware of each other. So to make sure that is happening, first we apply frame wise attention to each image so that the information inside the image is being mixed. And once it is being done, then the images must be allowed to talk to each other using global attention. And once this is done, then now the tokens are aware of each other and each image and can be used for all these dense 3D tasks.